Okay, so far in the lesson, we've gone over graphing parabolas using the 4 key features. We've gone over the average rate of change, which again is nothing more than the slope of a secant line between the first and the last point. And now we're going to move on to our final section, which are the business applications. We have 4 or 5 word problems that we're going to work with here. These word problems are posted on D2L. If you want to go back and review them later on, but we're going to work them out here together. So let's look at number 1. We have a small appliance company who has a daily cost and revenue given by the following. We want to determine the maximum profit and the corresponding number of units which yield the maximum profit. Then determine the average rate of change in the profit between 100 units and 140 units. So we're going to utilize here those first 2 big sections that we talked about. The first thing that we need to understand is that when it comes to our word problem, we want to know what we're looking for. We're looking for maximum profit, right? So maximum profit means we need a profit function. To get to that profit function, please remember that profit is equal to revenue minus cost. And so we ask ourselves the question, do we have revenue? Do we have cost? And of course we do, so we can find the profit. Now, because we're looking for maximum profit, the question becomes, where on our parabola, since these are quadratics, where on our parabola will we find a maximum? And I hope you come up with the idea that our maximum, right, is going to be at the vertex, which means we're going to be using x is equal to negative b over 2a. So you can start to see, once you have the basics of the parabola in your head, how to make some applications here. So let's move on to creating our profit function. The profit function will be revenue minus cost. And I do want to remind you that the most frequently missed portion to this problem is this negative sign. This negative sign has to be distributed the entire way across the cost. So we'll start with revenue. Revenue is equal to negative 0.9x squared plus 285x. Now we're going to subtract our cost, and because we're subtracting the cost, every sign in cost is going to change. Minus 0.1x squared, I'll try to squeeze this in here, minus 35x, and minus 15,000. And then it's just a matter of collecting our like terms. And as we collect our like terms, we'll come up with our final profit function. Well, let's take care of our squares first. Negative 0.9 and negative 0.1. We add those together and we have negative 1, so negative x squared is our leading coefficient. We have 285x minus 35x, which should be 250. And then we just have our constant at the end, 15,000. At this point, we want to remind ourselves that we're looking for maximum profit. That maximum profit, again, is at our vertex, which means now that we have our profit function, we can go x is equal to negative b over 2a. Off to the side, it doesn't hurt to write down a is equal to negative 1, b is equal to 250, and c is equal to negative 15,000. Okay. If that is true, x is equal to negative 250 over 2a, which is negative 2. A negative divided by a negative is going to be a positive. 250 divided by 2 is 125 units. Okay, now it's important to go back. We know that 125 units will give us a maximum profit. We want to make sure that we understand that we want to make sure that we answer the question. It says up here, determine the maximum profit and the corresponding number of units which will yield that maximum profit. Okay, well, we have not determined the maximum profit. We've been dealing with X. We've determined the corresponding number of units which will yield the maximum profit. The question is, how do we come up with the maximum profit? And it's not too bad. We just take our profit function and we evaluate it at 125 units. I'm going to hit pause here so I can grab a calculator and we can do that work. Okay, at this point I just want to talk about using your calculator in a smart way. Sometimes students will do a variety of calculations one line at a time. I just want to remind you that you can type into your calculator the entire expression. So you can see that we have a negative. I put the 125 in and squared it. You'll notice that my square is apart from the negative, because if you look at the original problem here, we're squaring it, and then we have that multiplication of the negative out front if you follow the order of operations. And then just 250 times 125 and minus 1500. If you type it all in at once, simply hit enter and you can get your final answer. In this case, 625. And so when we come back here, we write 625. We're going to put dollars, right? And if this was a test, we would write a summary sentence. The maximum profit is $625 daily, since if you go back to the original problem, it was a daily problem, at 125 units produced and sold. So that's the first part of the problem. The next thing we need to do is when we come here, it asks us to determine, turn my light back on, the average rate of change in the profit between 100 and 140. Now you might remember that average rate of change was really a slope problem, which means if we have x is equal to 100 and x is equal to 140, what we need is those corresponding y values. And again, we can go back to our calculator. I need to turn the light off so that the glare is not too bad. Okay, we're back at our calculator, and the only thing that I did here is I typed in the expression. Instead of putting 125 for the maximum like we did before, I put 100 in and 140 respectively, and you see that you have corresponding y values of 0 and 400. And so the output for 100 was 0. The output for 140 was 400. And then to get the average rate of change, it's pretty simple. The language that we use for this, delta, of course, is change. This little line across the top, that bar, means average. So delta bar is going to be equal to y2 minus y1 over x2 minus x1. And it never hurts to identify what is your first or your second ordered pair. In this case, we're going to have, I'm going to call this bottom one. This is going to be 0.2. The top one's going to be 0.1. So when we make our substitutions, delta bar is equal to, well, y2 in this case was 400 minus our y1, which was 0, over our x2, which was 140, minus our x1, which was 100. Well, from there, we're going to get 400 over 40. 400 over 40, or 10. And to be more specific on this, please remember y represents, in our problem, profit. X represents units, so this is dollars. This is units down here. We have dollars and units. And so the appropriate response is $10 per unit. $10 per unit. If we were to ask the question, what is the average rate of change in profit from 100 units to 140 units? The correct answer is the average rate of change, or that delta bar, is $10 per unit.